Hello and welcome to Algebra 2, Chapter 6.3, Adding, Subtracting, and Multiplying Polynomials. So let's get started. Key thing when you're adding, subtracting, combine like terms. I know you've never heard that phrase before, so you might take a second, write it down, so you can refer back to it. Combine like terms. Alright, so when you are adding, that is all you are doing, is just combining like terms. The only reason there's parentheses here is because it wants you to see you have a trinomial plus a trinomial. Those parentheses mean nothing else because there's nothing on the outside to distribute. So all you have to do is combine your x squareds, because you should be writing these in descending order. Combine your x's, watch your signs, and combine your constants. There you go. Done. One other way you can do it, if you would prefer, is to write them vertically instead of horizontally. And we'll just write the plus 8. You might have to leave gaps if there's missing terms. Then we have 2x to the 4th minus 9. And you are just adding these together, so there's a 3x to the 4th plus 2x cubed minus 1, and there's your answer. So when you subtract polynomials, there's just one extra step, and it's to make sure that you are figuring in this subtraction sign in the middle. You are subtracting this whole polynomial, not just the first term. And so my suggestion is that you distribute your subtraction sign and rewrite it. So what I do is I write it completely without parentheses. So there's the first polynomial. And then this is going to be minus 5x cubed plus x squared minus 17. From there, combine the like terms. Looks like we have negative 2x cubed. And if it helps to cross them out once you've used them, plus 9x squared, because that's x plus 1, minus x minus 22. Okay, and then there's your answer. The other way is you could still do these vertically. Do the first one on top. I'm going to leave a space for that 8 in the other one. And then go ahead and distribute that minus sign and figure it in here. So I'm going to write minus 3x to the 4th plus 12x cubed plus x, so that all of those minus signs have been distributed, and then still add these equations together. 6x to the 4th, the x cubes cancel, plus x squared plus x minus 8. So that's what you're doing. You are combining like terms. Alright, so on to multiplying. And really, to multiply, you are just going to distribute. So you're going to multiply each term in the first polynomial times each term in the second polynomial. Okay, so looking at the first one here, I would go in order, and you should have some order just so you don't get lost along your way. I would distribute the 4x squared to the binomial, so that's going to be 8x cubed, because remember, when you multiply, you add your exponents, plus 4x squared. So there's distributing the 4x squared. Then I would distribute the x, and you're going to get plus 2x squared plus x. And then you're going to distribute a negative 5, so it's negative 10x minus 5. From here, you want to combine your like terms. So let's see here, we're looking at 8x cubed plus 6x squared minus 9x minus 5. And there's your answer. Okay, so looking at the next one, I would distribute my x first. 5x cubed plus 3x squared minus x. Then I would distribute the 2 plus 10x squared plus 6x minus 2. And then you're just going to combine your like terms. 5x cubed plus 13x squared plus 5x minus 2. There we go. Okay, so what happens if you're multiplying more than two things? Well, you can't multiply more than two things at once. And so what you need to do is just multiply two of them, for instance, the first two. So if we FOIL here, we're going to have x squared minus x minus 2x plus 2. That was first, outside, inside, last. Combine like terms. Okay, and then I have that trinomial times x plus 3. So even if you're multiplying 2 times 3 times 4, you can't multiply all three of those at once, but you can multiply two of them, say 6, and then multiply that times the third one. And remember that multiplication is commutative, so if you would prefer to multiply the second two first, you're going to end up with the same answer. Okay, so to finish this, I'm going to multiply the x squared. I'm going to have x cubed plus 3x squared. I'm going to multiply the negative 3x. So negative 3x squared minus 9x. And then I'm going to multiply the plus 2. So we're going to have plus 2x plus 6. Combining all of those terms gives us x cubed. X squareds cancel, so minus 7x plus 6. So here's a list of special product patterns. Okay, and the first two actually, or the first three lines, but the first two special products you have seen before. The first one is the product of a sum and a difference. And notice that it only, when you multiply a sum and a difference, so it's a plus b, a minus b, remember those are conjugates. Those are conjugates of each other. We talked about that a little bit in chapter 5 when we were doing complex numbers and we were dividing. So when you multiply those, the middle terms cancel, and it leaves you with just a squared minus b squared, and it's always going to be minus because you're multiplying a positive times a negative in there. Okay. The second one is the square of a binomial, and you have to remember when you square anything, the definition of squaring something means to take it times itself. So if I took a plus b times a plus b and I FOILed that out, that is what I would get. Okay? So the same thing is if I took a minus b times a minus b. So the last one is the cube of a binomial, and that is if we had a plus b cubed, that is a plus b times a plus b times a plus b. And it gets to be a little hectic to work it out, not undoable by any means. But here we have given to you the special pattern for the sum or difference for a plus b or a minus b. So I would definitely write those down someplace, or I would make note that they're on page 339 in your book. Alright, so let's use those special patterns. And by the way, these aren't anything that you have to have memorized, because you could always just do the math and work it out. So let's see here. The first one is the product of a sum and a difference, because see how they are conjugates of each other. So what you just wrote down on the previous slide was this is going to be a squared, and I shouldn't have done a parenthesis. Let's do a squared minus b squared. So here's a, this is a minus b, this is a plus b. So when you multiply them, you get a squared, which is 9x squared, minus b squared is 4. And so the point here is just, can you plug it into that special pattern? Alright, so the next one is the square of a binomial, and it should fit into the a plus b category. And so you just wrote down this is a squared plus 2ab plus b squared. So this is a, this is b. So a squared is 25a squared plus 2 times a times b. Well, a times b is 10a. Twice of 10a is going to be 20a. plus b squared is 4. And the last one, this falls into a minus b squared, which you wrote down as a squared minus 2ab plus b squared. And again, this is a and b. So a squared is 4m squared minus 2 times a, and b is just the 3. You can ignore the minus sign in there. So that's going to be 6m. 6m times 2 is 12m plus b squared is 9. So there's your answers. And if you don't follow the patterns, just try to multiply it out on your own and you should get that same answer. Alright, from 1985 through 1996, the number of flu shots given in one city can be modeled by A equals negative 11.33 x to the fourth minus 8.325 x cubed plus 2,194 x squared minus 4,190 x plus 7,592 for adults, and by C equals, we're going to say etc. for children. Alright, where x is the number of years since 1985, write a model for the total number of flu shots given in those years. So if we want the total number of flu shots, we're going to need the number of flu shots for the adults plus the number of flu shots for the children. And so if we call T total, it is going to be A plus C. Alright, so we need to add these together. So I'm just going to write out the adults. And we are going to add to it, and I'm just going to add these vertically. We're going to add to it the children's. That's a negative. If you would prefer to add them horizontally, that's fine. Or if you would prefer to add them from the equations and not have to rewrite them, that's fine. Alright, so we're just going to add each one of these columns together. So I get negative 18.2 x to the fourth plus 97.625 x cubed, and please don't round, just leave it exact there, plus 1943 x squared. Oh, don't know what happened there. We'll try x squared again. There we go. Minus 4,055x plus 8,132, and that would be the total equals that many shots. Alright, so from 1990 through 1996, the number of students S enrolled during the fall semester and the average number of credits C carried by each student can be modeled by S equals that expression and C equals 0.25x plus 15, where x represents the number of years since 1990. Write a model for the total number of credits carried by students x years after 1990. So we really need to make sure we understand what these variables are. So S is the number of students, and C is the number of credits per student. So if we want the total number of credits carried by all the students, we actually need to multiply. So if you had 100 students and each student carried 5 credits, you'd have a total of 500 credits. So we need to multiply these here. So I'm going to go ahead and I'm going to put the 0.25x plus 15 out front. Doesn't matter the order, and we're going to multiply by 134.56 x squared minus 1,417x plus 26,628. So we are just multiplying these together. We get 0.25 times 134.56, 33.64x cubed minus 354.25x squared plus 6657. So there's the first distributing. Then we're going to multiply by 15. And we're going to get, let's see here. That would be an x squared, so I'm going to put it under the x squared. It's going to be a positive 2018.4x squared minus 21255x, in which case I'm going to move over. Oh, here's what I'm going to do. I'm going to cross that out and put it over here. And then this is going to be plus 399420. And so when we add them together, our total number of credits T equals 33.64x cubed plus 1664.15x squared minus, now I know you probably all caught this, that was right, and I forgot my x, didn't I? Because that should have had an x on it. Okay, so let's try this again. Minus 14598x plus 399420. That's how many total credits there would be. All right, that's what we have today. I hope you have a great day, and let me know if you have any questions.